In this particular problem, we're looking for the equation of a tangent line, and we need a point and a slope. And we can quickly determine where the point is by taking f of 1 and saying, well, that would be 2 minus 1 raised to the 5th times 1 plus 1. And that, of course, is 1 to the 5th times 2, which will be 2. So we have a point at 1, 2. Now we need to find the slope, and of course the slope is the derivative. And the derivative will be, well, we've got to use the product rule, so it'll be the first times the derivative of the second, which is 1, plus the second, which is x plus 1, times the derivative of the first. And this is the chain rule, 5 times 2x minus 1 raised to the 4th times the derivative of the inside, which will be a 2. So now let's just go right ahead and put in 1 and see what happens. So won't we get 2 minus 1 to the 5th times 1? I won't even write it. Plus, won't it be 2 times 5 times, well, 2 minus 1 will be 1 raised to the 4th times 2. And working on this just a little more, won't we get 1 to the 5th? Plus, don't we have 2 times 5 times 2, which is 20, for a total of 21. So our slope is 21. So putting it all together, what do we got? Well, we got y minus the one y we know equals m times the quantity, m times the quantity x minus the one x that you know, and the x that we know is 1. So getting it into the slope-intercept form, wouldn't it be y equals 21x, minus a 21 plus 2 would give us a minus 19. So B is the answer here. Number 7 would have us use some substitution, allowing u to be the square root of x, which of course is x to the 1/2. The derivative would be 1/2 x to the minus 1/2 dx. We have here du equals 1/2 times 1 over radical x. I hope you recognize this as 1 over radical x dx. And that's what we have in the problem here. But we don't have this 1/2. So we're going to double both sides and say that's 1 over radical x dx. So I put in 2 du into this entire problem. I put in 2 out front with a du to take the place of the 1 over radical x dx. And then I'm going to have e raised to the u power. That, of course, is 2 e to the u plus c. If we back substitute, we are talking about choice A. A is our answer. This is talking about trapezoidal approximation, and we've got x values along the x-axis at 0, 2, 4, and 6. We have some heights given, 4. The second one is given as k. We don't know what it is. The third one is 8, and the last one is 12. If we build some trapezoids, they're going to take on this appearance. I really don't know what this k value is, so I don't know if it's taller or shorter than I gave it. It really doesn't matter. What I need to know is the trapezoidal approximation formula. T sub n equals 1/2 times delta x times my, f of my first x, right? My x sub 0, and then twice my f of my x sub 1, and then twice my f of my x sub 2, etc. And I keep going, as you recall. And then when I get out to the end, I have 2 f of x sub n minus 1. The next to the last one is doubled. And then the last one is just included. The last one is going to be an f of x sub n. That's if I've got n. To do on this one, I've just got 3, right? So it's kind of nice. I got 3 trapezoids, and it's going to be 1/2. My delta x happens to be 2. That's a very nice development. My first height is 4. So I got a 4 plus, and then I've got a 2 times k, because this is doubled up. I don't know how tall that one is. And then I've got a 2 times 8, and then I've got a 12 on the end. Let me slide this over and write my 12. And the problem says that all that is supposed to equal 52. So let me extend slightly and say, well, that's supposed to be 52. So remember this nice development in the beginning. This nice development in the beginning would make that 1. So we have 4 plus 2k plus 16 plus 12 equals 52. So if I bring 4 and 16 together, I get 20, and 20 and 12 make 32, and that equals 52. So if I take 32 away from both sides, I get 2k equals 20. K must be 10. So going back to the problem itself, D must be my answer. Problem 9 would have us recall that the accumulation of velocity is distance. And so in this particular case, we're interested in what happens between time 1 and time 2, and we're going to use integration, which is the accumulation function, and it's the accumulation of the velocity. And the velocity is given by 4 minus 6t squared. So integrating, we get 4t minus 6t cubed over 3, which settles down to 4t minus 2t cubed. And we're going to put in 2 and 1. And so if we do that, we get, on the upper, we get 8 minus 16. If we put in the upper limit, 2. And then if we put in the lower limit, 1, we get 4 minus 3. And we get a negative 8 minus 2 more, which is negative 10. So this is the change that happened between 1 and 2. We started off at 7 at time 1. We started at 1. We started, rather, at 7. Our change in distance was down 10. So our result, we end at negative 3. And so C is our answer to number 9. We're asked to identify what A and B are. We've got 2 asymptotes. Let's concentrate on the vertical asymptote first and recognize that for this function, our denominator at 2, f of x, when x equals 2, does not exist. D, N, E, right? That's what the asymptote is saying. Well, that'll happen when the denominator is 0. So if we focus on the denominator, x squared plus b, when will it equal 0? Well, if we put 2 in, we get 4 plus b equals 0. It must mean that b, it suggests that b is equal to a negative 4. And as I look to the list, I only find D where b is negative 4. You can confirm this further if you know about horizontal asymptotes, and they are of equal degree, numerator and denominator. It suggests that our lead coefficients, 3 over 1, would be that point where our horizontal asymptote would be 3. That means our lead coefficient A has to be 3. A over 1, it must be 3, and that's because this horizontal asymptote is 3. So it further confirms the choice of D.